Good afternoon, everybody. I'm Amir Reza, PhD student in signal processing at LTU, and today I will talk about cellular coverage inequality. With increasing dependency to cellular networks, there are still people or there are still areas that do not access to cellular networks. The gap between areas or individuals with access to reliable cellular coverage and those without access to that called cellular coverage inequality. And it can be due to many reasons, like it could be due to lack of infrastructure. It can it can have something to do with the attitude of the people, or it can have something to do with the income, education of the people, or it can have some reason due to the geographical aspects, like rural areas or remote areas. If we want to have a look at the rural area, there are some challenges for mobile coverage in those areas. The first thing is there are fewer cell towers there, which can lead to dead zones or it can lead to weak signals. The other thing is there are some geographic barriers, like there are mountains, forests, and huge lakes that can maybe consider as a barrier. And lastly, the sparse population there is some hinders that operators usually do not like to invest in those areas because there are less people living there. And of course, there will be some consequence for people who live there or not living there, actually working there, or maybe crossing those areas. For example, they cannot communicate with other people, and it's really important, especially during emergencies. And the other thing is it can lead to that an area won't develop and it cannot access to e-commerce. And the other thing is it's really crucial for education, healthcare, and other economic development, and also entertainment as well. The first thing to bridge the this divide is to get installed more base station. But the thing is, first we have to have a look at how to measure this coverage. Usually, operators measure coverage by the percentage. That means they just count that how an area of the country has access, and they divide it to the whole area, and then they can have we can have a coverage percentage. But this number usually does not provide any information about the distribution of coverage. We cannot have any idea that how this coverage distributed in a country, like what's the coverage in rural area, how's the coverage in urban area. And the other thing is expanding coverage is really good, but it's usually does not happen in rural areas, and it usually happens in urban areas, which leads to the increasing this inequality. In this work, we propose a novel cellular coverage inequality index that measures the correlation between the rurality and coverage, and it can show us that the how coverage is distributed in an area from the micro perspective to macro perspective, and how it expanded. In order to introduce this index, I will first talk about how a method to create a rurality map, and then I will discuss how to create a coverage map, and then with those information I will introduce the cellular coverage inequality index, and finally I will use Sweden as an example. And let's begin with the rurality map. Suppose this is a country, this is a fictional country. We want to create a rurality map for it. And let's say this country shaped with a certain number of points. Let's call this set A. Now we just collect the location of cities and villages with population equal and greater to a certain number. For example, in this country, we have three population classes, 50, 500, and 5,000. What we are interested is the shortest distance between each of these points and the location of these cities. For example, suppose we want to measure rurality for this cross. We first look for the shortest distance to the first population classes. That means we are looking for the closest distance with the cities more than 50 people, which are all those 6 cities, which is this one. And then we go to the next classes. It's greater than 500, which are these 3 cities, and it would be this one. And lastly, we have for the 5,000. And then finally, in order to create a rurality map, we will just take an average of all these distances, and then the rurality degree of this point can be measured. If we do this process for all the points in this fictional country, then we can create a rurality map. Like you can observe, there are 3 rurality map for the 3 population classes, 50, 500, and 5,000. And if we take an average, we can have the rurality map. On the right side, you can observe the rurality map and the darkest color indicates for the least rurality, and when the color tones getting lighter, that indicates for the most rurality. And you can observe in the southwest of the country, you can see the extreme rurality, and there are also the borders between those cities are clear in these areas. And then on the second step, we will discuss about the coverage map. Usually coverage maps can be created if we suppose, for example, if the point X can receive at least 30 megabits per second of data rates, it can consider as it has coverage, and otherwise not. For example, in this fictional country, these gray circles indicates for the coverage. You can see these areas have coverage, while this white area has no coverage. And then with those map, rurality map and coverage map, we can measure the cellular coverage inequality index. In the left side, you can observe again that coverage map and rurality map. And you can observe that this in the southwest, there's extreme rurality, and also there's no coverage. But how we can relate that? First, I will introduce a concentration index. The concentration index can show us the inequality and the distribution among 2 unrelated things. In here, like rurality and the coverage. On the axis is the proportion of online ports, and on the vertical axis the proportion of online points. We just sort each point from most ruler to least ruler, then we will create our concentration curve. And after that, by this formula, that means that by dividing this area enclosed between the line of equality and the concentration curve, we can measure concentration index. That means this curve, if this curve getting closer to line of equality, that means the fairness also increases. And once the curve overlap the line of equality, that means the fairness is totally fairness actually, and it's 0. And now let's try Sweden as an example. You can observe the rurality map for Sweden. This data is provided by SCB. Sweden, we divided Sweden into 5 population class: 200, 1,000, 3,000, 30,000, and 60,000. And then we take an average. That means now you can observe the Sweden's rurality map, and you can see these dark areas indicates for the most urban, while this yellow in the case for the most rural areas. And you can observe that when from the middle of Sweden we go to the north, the rurality increases, and there are extreme rurality in the north and northwest of Sweden. And now let's have a look at Sweden coverage map. In this figure, you can observe Sweden's coverage map for data rate of 10 megabits per second from 2013 to 2020. In 2013, you can see that most urban area of Sweden has access to the 10 megabits per second, and it increases until in 2030, almost 85% of Sweden can access to 10 megabits per second. And those areas that has no access to internet are mostly in the north and northwest of Sweden, where there's extreme rurality there. Also, in this bottom figure, you can observe the map for the 30 megabits per second. In 2030, let's say just big cities like Stockholm, Malmö, Gothenburg, and Umeå had access to 30 megabits per second, and the years go by, coverage expanded until in 2030, most of the urban areas in Sweden could access to 30 megabits per second, while rural areas cannot benefit from that. Now, we apply the CCI index for the Sweden. In this figure, on the horizontal axis, you can observe the coverage percentage, the traditional, which usually operator use from 0 to 100%. On the vertical axis, you can observe a CCI index from 0 to 1. 0 means total equality, while 1 indicates for the least. And you can observe in 2030, around 42% of the Sweden has access to 10 megabits per second, and in 2020, around 85 or 86% of Sweden benefit from 10 megabits per second. While for the 30 megabits per second, well, in 2030, only 2% of Sweden benefits from 30 megabits per second, and in 2020, roughly 18% of Sweden. But in the matter of CCI index, you can observe until 2018, the fairness start to increasing. But after that, for the 10 megabits per second, the fairness also decreased. That means more urban area benefit from cellular coverage. In 30 megabits per second, again, until 2018, there was really good progress for the increasing the fairness. But after that, again, the fairness start to increase. And our desired direction would be in this direction. And the desired direction only occurs when coverage expansion happens in area with most rurality matches that of least rurality. And in conclusion, we introduce a method to create a rurality map based on distance. Then we discuss about how to create a coverage map. Then we propose CCI index. And lastly, we used Sweden as an example to measure CCI index. Thank you.
Good. Thank you, Amireza. So, any questions? I'm looking in the Q&A right now. I don't see any questions. I can a quick question from my side, Amireza. The coverage maps that you showed, are they so for Sweden typically, right? Those maps for through the years. Are they from one operator or from several? How can you say
No,
a little
it's
bit about how you got them and where they come from, the data?
the data is provided by PTS,
Yeah.
and it's the aggregation map from all the operators. It's not only one operator like Telia or Comviq or Telenor. It's aggregation of all the operators. That means if you just focus maybe on one operators, maybe the coverage percentage, the classical one, is not like in 2020, it won't be like 85%. Maybe the number would be, probably the number is less than that.
So if you would have access to this data from several different operators separately, this could also be used then possibly as to compare different operators, or?
Yeah, you can see what operators invest in rural area, while most operators have really good coverage in urban area like Stockholm, Gothenburg, Malmo. But when you move to rural areas, usually they're really not interested.
Mm. Mm.
But still people live there.
Yes.
I think they have right to benefit from cellular coverage.